Okay, we've got 4 guided practices to go through for our first lesson on logarithms. The first guided practice is about writing each statement as a logarithm. So you've been told that log with base a of n is equal to x. That means that a to the power of x equals n. Now this might seem really abstract to you at the moment. When we go through examples, you'll kind of understand that a bit better, and the use of this is that it's going to really help us with solving equations when we have powers that are of x. So the first example we're going to look at, we've got 3 squared equals 9. So if we know that log log an equals x implies that ax equals n. Well, here we've got a is equal to 3, x is equal to 2, and n is equal to 9. So 3 squared equals 9 implies that log a is our value here, so that's 3. So we've got base 3, n is going to be 9, and that's equal to 2. So what this is saying is 3 to the power of 2 is equal to 9. The next one, we've got 2 to the power of 7 is equal to 128. So we've got log, the base is the number that we raise into a power, so the base is 2. We're doing log base 2 of 128, and that's equal to 7. So if, for example, we were given a question where it asked us what power of 2 gives you an answer of 128, in your calculator you would do log base 2 128 and you would get the answer of a power of 7. The last one, we've got 64 to the power of a half equals 8. So our base is 64, our answer is 8, and our power was a half. So we've got log base 64 of 8 is equal to a half. Our second guided practice is doing the opposite. So we're given a logarithm and we're asked to write it as a power. So the first one, we've got log base 3 of 81 is equal to 4. So I've got a base of 3. Whatever it's equal to, that is the power I've raised my base to. So I've raised my base to the power of 4, and my answer is 81. The next one, I've got log base 2 of an eighth is equal to negative 3. So base 2 to the power of negative 3 is equal to 1 over 8. For guided practice 3, we are given a logarithm and we want to work out what this logarithm is equal to, but without using a calculator. So if we let this equal x, what we're trying to work out here is what base 3 to the power of x is what x is equal to when base 3 is raised to the power of x, and the answer is 81. So you need to think now of your powers of 3. We know that 3 squared is 9, 3 to the power of 3 is 27, and we know that 3 to the power of 4 is 81. So we're going to say x equals 4. Again, for the next one, I'm going to set this one equal to y now. So we're trying to work out base 4 to the power of y is equal to 0.25. I'm going to rewrite that as a fraction, and we should be able to see, using our laws of indices, what our value of y is going to be. We've done 4 to the power of y, and we've got the reciprocal of 4, so y must be equal to negative 1. Part C, I'm going to say that log base 0.5 of 4 is equal to z. I'm going to rewrite this using my powers. So 0.5 is my base. I'm going to write that as a fraction. I'm raising that to the power of z, and that is equal to 4. Now I know if I take the reciprocal of a half, my answer is 2. And I know that 2 squared is 4. So z must be the reciprocal squared, or essentially z is equal to -2. So we've taken the reciprocal, then we've squared it. -1 times 2 is -2. The last one then, this is in algebraic terms, so we haven't got any integers here, we're doing it in terms of a, but it's exactly the same. So we're going to say log base a to the power of 5, we're going to call that, let's call that s. So I know that my base is a, so a to the power of s is equal to a to the power of 5. Okay, this is really easy. We know that s then must equal 5. Just comparing those powers. For the final guided practice, we're now going to be using our calculator and deciding which logarithm button we're going to use. Now, on the slide for the guided practice, you've been given a little information box about the different buttons on your calculators. So, if you look at your calculator, you've got this button here on the top right, that log button, where you can put in any base and then any number there. Now we would use that if our base is anything other than e or 10. If we've got a base e, we can use the button directly underneath it, ln. So ln is what we use when we've got a base e. Now if we've got a base 10, then we can use the log button. So that's the one to the left of ln. So that log button is when we've got a base of 10. Now technically you could use that top right log button there and put in a base of e, or put in a base of 10. However, once we start to really gain an understanding of the ln being an inverse of e, that ln button is going to become really useful. So, the first one, we've got log base 3, 40. So for this one, we're going to use our normal logarithm button. So we've got log base 3, 40, that's equal to 3.36. I'm just going to do it to 3 significant figures, but you can see the full answer there. The next one, we're doing log base e of 8. So I'm doing base e, which means I can just use that log button, that ln button, and then put in 8. And we get 2.08 to 3 significant figures. And then the last one, we've got log base 10 of 75. So here I can use that log button and put in 75, and I get 1.88 to 3 significant figures.